Okay, hello. For for the first queue will be Thanapoom, and the next will be Sukhasem ครับ
Good morning ครับ No good afternoon ครับ
Okay.
So I start by playing my video, right?
Okay.
Hello, good morning, and welcome to my project presentation. First, I'll be introducing you to my project, then I'll talk about the software, the hardware, then I'll talk about the process itself, the motion detection, the plate detection methods, the dataset I'm using to test, the result of that test, and then exploring the method that was working the best. Right, so firstly, let's move on to the concept. So the concept of this project is a license plate reading system based on Python, which will be able to read license plates in real time. So for software, this project is based on Python with the following libraries. So there's OS for command line interaction, time for tracking runtimes, NumPy for exporting results, CV2 for reading and processing images, EMU2s for image processing, and PyTestRec for optical character recognition. So next is the hardware. So in developing and testing this project, I use my desktop computer, my laptop computer, and a USB webcam. Right. So here's how the motion detection works. Motion detection is done by comparing two captured frames, and the libraries used in here are CV2 and IMU2s. So the flowchart goes like this. So at the start, it takes images and compares them. If there's no difference, then it keeps taking images, and if there finds a difference, then it runs like the license plate recognition program. So next is the code for motion detection. So the first step is resizing the image, and then the image gets converted to grayscale, and then it gets blurred. The next block of code is to make sure that the motion detection is not too sensitive by resetting the reference image every 100 frames. Then if motion is detected, then it runs a comparison. So for the comparison function, it loads two images, the base one and the current one. Then it enhances the difference by finding the absolute difference, applying thresholding, and applying dilation. After that, it finds contours and places it in a list, and then it loops to a list returning true if the contour area exceeds the predetermined amount. So next is the plate detection method. So there are three main methods, method A, B, and C. Method A is focused on finding borders and then identifying frames that it thinks could be belonging to license plates. It will look for candidates and then attempt to read any text in that area. Method B is different since it focuses on finding contours and then finds potential strings. Then it finds the highest sequence of strings that are next to each other and then it combines them to return a license plate. Method C is an advanced prepackaged model which I'm using as a baseline. Right, so next are the datasets. So dataset 1 is a self-captured dataset with images with different variables. So there's different lighting conditions. As you can see, I took it at night, at evening, and during the day at different speed at 30, 20, and 10 kilometers per hour. But this doesn't seem to have much of an effect in good lighting conditions, and with different vehicles just to make sure that there are no weird bugs. So for dataset 2, I use image of Thai cars gathered from the internet. So next is the performance, and first is the accuracy. So I checked this by finding the successful detection of at least 3 characters, and of course higher is better. So here method B significantly outperforms the other two methods. And next is speed. So I took this by taking the average time taken for successful detection in seconds. So here method B takes the longest at 0.73 seconds. So since method B is really successful, let's have a deeper look into it. So method B starts by finding the contours and then it finds the potential characters. Then it finds groupings of those potential characters to find potential plates. After that, it processes each individual plate to find the most likely candidate and then returns the result of that license plate.
อาจารย์ครับอาจารย์ไม่ได้เปิดไมค์ครับsorry I meant you didn't have your mic on.
All right. Okay, very good. I have a few comments, but I'll come back to you maybe at the end at 4 o'clock because as to get you going, we want to keep to the time. So let's go to the next person. Okay, very good. Okay, Kap. The next person is Sukasem. You're up.
Yes, okay ครับ
Okay. Normally, I'll try to keep the comments right after. Okay, Kap, Sukasem, you're up.
Okay I'll share the screen ครับ
And Pinat, key in the next person after Sukasem.
Asian. The project is about using Thai language natural language processing model to classify daily spending type for money tracking purpose. So let's move on. Firstly, this is the mind map that I created that will summarize all the content that will be included in the presentation. So the content will be from objective to data processing result and future works. So let's get into it. So firstly, why I want to do this project. So I had a project that I do with my friend. This is about creating a money tracker application, and one of the main features that is to classify the type of spending that the user input in the information, but we got stuck because we can only at the time we can only predict the spending in English version, but the main customer that we target is the Thai people, which is not ideal for the customer to always use English. So I wonder that is it possible to make the program that can do what my team want, and I will try to do it now. So the objective of this project is to create an algorithm that can receive Thai language text as an input and identify the words in the sentence. Then the program can understand the words and context of the sentence given. Then it can specify the given sentence to a specific type of data, and then predict new inputs that are not in the database before and it haven't seen before. The second objective is to analyze and visualize the performance of the algorithm that I created. So looking at the data, it is a CSV file, contains 316 by 3 values. So the 3 columns are text, type, and price. Text and type are strings, and price are ratio numbers. So the file is encoding in UTF-8 numbers, and the numbers of labels are 8 labels, which is clothing, equipment, finance, food, healthcare, income, relax, and transport. So these data are hand generated by me, and the source is in the GitHub link below. So the method I will be using to creating a model is called BERT, which are bidirectional encoder representation from transformer. As the name say, it is adapted from transformer, which previously using to create natural language processing model. So it can be stated that BERT is the improved version of transformer that are specifically for using in natural language processing. All of these are supervised learning. So moving on. So the process I do to create the model is firstly I separate the data into train and test data set. So the train data set will be 265 rows, and the test data set will be 51 rows. Then I concatenate the data to make the every type is equally in amount, because it will prevent the bias in the significantly amount. And then I use function BERT pre-train model to fine-tune my data to create a classification model. Then I use the model to predict the test values and then the result. Then it output the result, which will be discussed in the next slides. So these are the results. I get a model that can predict the type of lecture given the lecture text is in Thai language. So as you can see from the slides, I input กินข้าวต้ม3 ย่าน80 บาท in the program, and the program will predict the value, the type of the lecture, which is food, in this which is correct, and it also will show the confidence level of each type that it thinks that it would fit in this type. So this is, I think, it is transport. It said that like it have some confidence level that it is transportation other than food. So for testing the test data, the result I got the model got a correct prediction of 34, which are the accuracy of 66.67%, and the precision and recall are as follow. These are the confusion matrix of the results, and these are the ROC graph and area under the curve of the result. Area are shown in the label, this one. So as you can see that the first coding is like the best of all.
Okay.
The model. The model is most confident on the codings.
Okay.
So for further works,
Let me cut you off.
further
So,
improvement, I think. Yes,
let me cut you off so that I can make a bit quick comment. We go to the next one.
Okay.
Very good. You haven't prepared the video, right? Correct? So I haven't got
Yeah,
that.
yes.
You haven't prepared the video, correct?
Yeah, the time is like I spend so much time on doing the model.
Okay. Now, for your model, I think it's got quite a lot to go. I mean, it's got a good potential because it can be used quite in practical use. Now, this is the bird, the Wangjan bird, right? This is the
Yes.
Thai language bird. That's very good. So this is a technology that as I may have told you, only came online in February of this year. So this is a very current, very sort of like cutting edge because it's using a baseline language model that only became available 6-7 months ago. So that's very good. I would recommend that you think about sharing this on paper with code. I'll talk about the presentation, the write-up format. I'll just give a topics of what you need to cover. But for some of you, for example, in this work, I think it might warrant sharing it on paper with code, in which case you should write it up in like a LaTeX format. Okay, I'll go talk about it later. Okay, so let's move quickly to Akrit. And then the next person would be Pooh.
Hello.
Go ahead, Kap.
Okay,ครับ.
You starting video or you just?
Yes, I'm playing my video.
Hello and welcome to my big data analytics presentation. My name is Chris. Here I pick a Bitcoin price dataset which include the time, open, high, low, close, and volume.
Up the volume a little bit.
Year 2017. Here we visualize the closing price of the Bitcoin market. And this project will be based on the visualization and support machine learning to analyze the crypto data. And then we can see that the market mostly shows up more than closing down. And here we visualize the price change. We see that there's a very large deviation going on. So yep, I'm just curious on where this large price change is coming from the high or from the low. Here we can see that it's mostly from the high, which is going up more than the going down. That's where the division is coming from. And yep, we plot them each. Here is the down part, and here's the up part. You see it's more on the up part. Yep, we calculated the standard deviation to confirm it. And yep, it's from the high. But however, when we calculating the mean, the low have more mean. And given the median, here's the distribution of the Bitcoin price, which I think it might look like a pattern. When zooming on the base, it might look like a log normal distribution, but yep, more favor than go more on this side. Here we plotted the price change is to 2%, 5%, 10%, and so on. And this one is for the division. Here we counted the occurrence to see like how many occurrences of it is the low, like from the middle point of the deviation, which is 5% to 20%. Here the low keep dominating, but however after that the high just completely dominates the low. Which is the same thing here for like 1 standard deviation to 20 standard deviation. Low just dominate the high. Then after that, the low just gone. Here we do a volatility visualization, which the volatility is derived from the standard deviation of each month. And here we do some k-mean to see that, oh, yep, there's 2 types. And then we see the correlation of it, which are quite correlated because, yeah, they obviously are derived from price. And then we analyze the volume, which here we can see that there's a large deviation going on again. And here we plotted the price on the y-axis and the volume on the x-axis to see what's going to happen. And then we do some k-mean. And yep, as you can see, the volume is pretty interesting. Then we plotted the volume with the volatility. You see, like there's like 2 types. Yep. Then we kind of want to see the correlation, so yeah, we sorted them out and then plotted them again. Here, so on my hypothesis, okay, here I added more data, which is Ethereum price, Monero price, Litecoin price, Dogecoin price. Okay, so since crypto doesn't have like a dividend or balance sheet, it will be like pretty hard to calculate the risk of the investment. So here's our hypothesis. The hypothesis is that if there's a large change in price without any volume, it will be like more like a bubble going to burst. Like imagine like one crypto going like 100% increase in price in a day and only like 1% increase in volume. That would be like very risky. It was like more than like a crypto going 100% increase in price and then 99% increase in volume. So yeah, we find the deviation of the volume to the price, which we calculated from the change in volume over the change in price, and then we plotted here. So remember, the less the deviation, the better, right? You want the volume and the price to correlate it. Okay, so here we plotted them out, and then I do a calculated from the mean, and then do a k-mean analysis again to see. Then we can conclude it into like a 3-part, which is a low risk of being a bubble, which is a Monero and Ethereum, and then like by the middle part is Bitcoin and Dogecoin. And the thing that didn't really correlate is Litecoin, which is quite dangerous to be a bubble. Okay. So that's conclude my presentation. Thank you.
Okay, very good. Can you hear me? Yeah.
Yes,ครับ.
Go to the use my phone here. Okay, very good. I think since this being prepared presentation, you should have started a little bit with where we're going with this. Okay, maybe your ultimate goal is to trade cryptocurrency, but right now you just want to visualize and you want to maybe separate them in terms of volatility and so forth. Okay, so your objective would be to say, well, what we just we're not going to the trading model or anything just yet, but we're trying to visualize using basic statistical criteria like volatility of price change and so forth, right? And then you can say that you're adding value to it by doing a little bit of a cluster analysis. Now, when you do cluster analysis, normally the individual data point would refer to individual entities. In which case, it would be something like looking at space of all the statistics, and you have 2,000 currencies. Cryptos, there are 2,000 cryptos, and you sort of like cluster different cryptos according to their overall behaviors. Now, I think what you were doing was clustering, I think, across time period or something like that, maybe a period of low volatility and high period of high volatility. So be when you're doing unsupervised learning, be very clear from the very beginning in your project as well as to the presentation, what it is represent an individual point. Okay, does it mean that let's say you're looking at just Bitcoin, right? In which case each data point may be volatility and volume over a space of 1 month. So you can see that certain months have low volatility, low volume, certain months have high volatility, high volume, and so forth. Or you can say that this is volatility and volume across all the time, across all period, but each individual point corresponds to individual cryptocurrency, right? So be very clear. I didn't get that that point in the beginning, so I kind of got lost a little bit about what you were trying to achieve there. But okay, it's very good, and you should sort of like encapsulate this, with some kind of interactive display so that you can bring up, say, I'm looking at Ethereum, Bitcoin, and Dogecoin, and I'm looking at, I can do a click and a button and say, I'm looking at volatility, I'm looking at mean price change, I'm doing this and that. So make it a more like interactive visualization tools. That would be good. Okay, instead of like producing different graphs and then the user would have to just flick through them. Okay, very good. And so, boom, you're up. Boom. And so that means next month, not forget.
Okay, let me share the screen.
Okay.
Pardon, are you presenting or not? Because I cannot hear you. Your video clip.
Oh, you cannot hear it?
Yes.
Oh, okay, I'll try again. Stop sharing.
By the way, you have to write down what the name of your project, of your friend's project is. So there's a field where you have to give the name and the description. So it might help your friend when you start your presentation, say, the name of my project is whatever. Okay, check up, go on.
So I'm from Blackmeshai. So today I'll be presenting to you my
Can you hear it?
project looking at
Peanut Cup, can you hear it?
Yes, we can hear.
Okay.
Let's go on.
Good afternoon, everyone. I'm from Mishai. So today I'll be presenting to you my term project with DataAnalytics. It will be mainly about unemployment and mental illness. So what is the main objective? It seems that mental illness has become one of the most common illnesses worldwide, with all the anxiety and stress, especially in the workplace. I also experienced it with my mother's friend who resigned from his current job due to mental illness and seriously not have any clue it was coming at all. So by modeling these factors, these stressed individuals could seek help and heal fast. So moving on to data collection. This data set is multiple surveys verifying the high unemployment rate among those with mental illness. But this is the only survey to date which targets causation, so why are they unemployed? Sample size is around 334 respondents with 103 diagnosed with mental illness. But this proportion is approximately equal to estimates of the general population diagnosed with mental illness. Typically estimated at 20 to 25% according to various studies. It consists of 335 rows and 31 columns. And it also represents nominal scale, which results as yes and no. So yes would be 1 and no would be 0. And from 31 columns, it would be 31 features and questions mainly on characteristics, education, and symptoms. But mainly in this project, I extracted 8 columns of symptoms: lack of concentration, anxiety, depression, obsessive thinking, panic attacks, compulsive behavior, and tiredness. Moving on to the methodology. This project is ought to be mainly about an accumulation of actions where I will cluster them into different groups of symptoms and then look at the center to evaluate what problems occur in their identities. After that, using data visualization to find tendency of the occurrence of mental illness that leads to unemployment, such as histogram. And after that, I want to classify each group and find the identity, uniqueness, and common factor within each individual. After that, I could predict the tendency and probability to develop mental illness and lead to unemployment. And actually, the one that doesn't tend to have mental illness could actually be blinded to that symptoms. And in the end, is the one who's having a problem. Okay, so moving on to data visualization. As you can see, I've shown number of illness and also all 8 symptoms to display that amount and which one dominates in terms of quantity. Here is one of the sample that I display and visualize one symptoms, the amount of yes and no, and also I count it all. Yes, here's another one, from tiredness. Moving on to unsupervised learning. I use cluster classify to separate all 8 symptoms and extract each of them to seek for which symptoms are common throughout the survey. However, it shows that this data couldn't actually cluster with only one class. Also, it suggests that I could use DB scan to visualize the result. I also continue to do cluster classify and try to train classifier function, use classifier function to classify a new unlabeled, data set, and also try to obtain classification probabilities and do multiple examples, which later plot the graph. However, my data set is nominal, so the result is impossible in terms of percentage. And I'll do further research on this when I submit the report. And here's my mind map, mainly touch upon machine learning, statistical methods, introduction, but I did touch mainly on fundamental stuff. Okay, so moving on to the results. As I recognized it from the visualization mainly and some of the cluster analysis, People in this survey have no clue on their tendency to have mental illness, especially not knowing their symptoms also, moreover, not even one symptom reaches more than 100 users. Therefore, we could make the assumption where mental illness patients did not know that they had it before. Yeah, that wraps it all up. So thank you very much for listening.
Okay, Cup. Very good. I think especially in terms of completeness, did ask for you to describe the data source. You even have the mind map to show where the idea is. You even you mentioned very early on that this project is about visualization and unsupervised learning. So it's very clear structure of where you're heading. So in terms of presentation, it's very good. The only thing I would say, first of all, is right now that's important is you wasted a lot of real estate in the slides. I think you have a lot of, big words in the back. I mean, literally big words and just a small, tiny graph. You can economize on that, right? Because that's the main feature is what you want to present. I think you should go to sort of like the analytical result first before you make the conclusion about what it is. You have to say that people don't realize that they have it. So you have to show the result of, say, the what does the scatter plot or the centroid of your samples look like, and so forth. So give it a little bit more analytical evidence, right? Rather than just jump ahead and say, well, I've looked at the data, I've run this, and then this is my conclusion. Okay. So normally the conclusion should pop out. If your presentation is done really well, if your graphic is done really well, you almost don't even have to say it. Okay, you don't even have to spell out the sentence. It should pop up. Oh, I can see what's happening with the mental health. Okay, but I think that's very good. Okay, Cup. So not Phuket, right? You're up.
Up home. Let me share my screen. Can you see it, Cup?
It's not start yet.
So
maybe please unshare and share. Okay, it's up now.
Okay. Oh, but my laptops have like the screen come like dark for a short period. Sorry. Hold on. Hi, my name is Dr. My topic is about predicting the risk.
Sorry, I cannot see this. Okay, it's up now.
Oh, can you see it, Cup?
Okay, cool.
Okay. Hi, my name is Dr. My topic is about predicting the breast cancer. Nowadays, breast cancer is the most common cancer in female, except for skin cancers. The average risk of a woman developing a breast cancer sometimes is about 13%. Big data can be a game changer in female breast cancer. It helps identify risk factors that could lead to breast cancer in the future. There are 5 main factors that lead to breast cancer, which I would like to discuss in the following slide. Here's the method and data visualization. Sorry, it looked like the screen didn't follow the description. Sorry, changer in female breast cancer. My screen is like freezing up.
Okay, maybe you can carry on playing the video.
5 risk factors that could lead to breast cancer in the future. There are 5 main factors that lead to breast cancer, which I would like to discuss in the following slide. Here's the method and data visualization. First is diagnosis. If you have been diagnosed with breast cancer, you are 3 to 4 times more likely to develop breast cancer in another breast or same breast with different parts of the breast. As you can see here, B is benign. A benign tumors are tumors that form in only one spot without spreading to surrounding tissue. There are 212 people in this data set, which is around 37.25%. M is malignant. The malignant tumors are tumors that are cancerous and can be spread to nearby tissue. There are 357 people, which is around 62.75%. This is the average of the texture mean. But next is the worst texture. The worst texture data with high average of pattern score. Female with higher texture pattern score has 3 times higher breast cancer risk than female with lower texture pattern score. Next is symmetry. If the breast is not symmetry, such as it's new or is having changed, it's called developing the asymmetry. If a mammogram screening identifies developing an asymmetry, there's around 12.8% chance for women to develop breast cancer. As you can see, an average of symmetry are between 0 to 2, but the worst symmetry, female who have the symmetrical pattern more than 3.38 has higher risk of breast cancer with approximately 12.8%. Next is the fractal dimension. The fractal analysis of images of breast tissue specimens provide a numeric description of tumor growth patterns as a continuous number between 0 to 2. This number, the fractal dimension, is an objective and measuring the complexity of tissue structure of a reproducible biopsy sample. An average fractal dimension is between 0.5 to 0.8. However, the worst fractal dimension have an average between 0.81 to 2. And this is the worst fractal dimension data. For the area, knowing the area is needed to predict breast cancer. Since there is specific area when breast cancer are most likely to occur, the outer quadrant of the breast is the most frequent site where the breast cancer is located. The data that represents is the area of the dark color skin around the breast nipple, which the breast tissue mostly start around this area, which lead to the breast cancer. The worst area is mean people who have a higher average of area of dark color skin around the breast nipple have higher chance to develop breast cancer. Here's my map. Thank you. It's finished, Carl.
Okay, Kap. I think you were overselling the project a little bit, because if you are making a prediction, you literally have to create a model that takes in all the factors and then predict whether or not this person has or does not have malignant cancer. In which case, you would actually have to show, ROC curve, confusion matrix, show about accuracy, precision, recall rate, and so forth. A bit like what your earlier presentation was. Now, what you were doing is actually visualization of basically just a histogram of the individual factors. Now, this would only make a good prediction. This would only translate into a good prediction if individual factor adds linearly to the prediction. In other words, if you can look at all the histogram, right? If you can look at all the histogram of all the values, and you can say something like for fractal dimension, if the fractal dimension is greater than 0.65, then you're more likely to have malignant as opposed to just benign tumor. And then you have to have individual cutoff point for individual attributes. Now, that's not how multivariate prediction works, because multivariate prediction means that the outcome of the prediction is not dependent on individual contribution. It's not just dependent on how fractal the dimension is. It's not just dependent on how asymmetric is, but it's a combination, okay? So right now you're just visualizing. So this would be a very good first phase, right, of a prediction problem, right? You're visualizing the input. You see if the input have variation, if the distribution is skewed and so forth. But then you have to build you do have to build some kind of prediction model. Otherwise, it's not a prediction problem. Okay, I guess the aim is very good, but I think it's a little bit under executed in terms of the model that's being built. Okay, Kap. Who's up next? Natnari, right? Okay, you're up.
Ajahn Krab, I have sent something to your line message.
Sorry?
I have sent something to your line message.
Okay, Kap.
Do I share now?
Yes,
Yeah, sure.
you are sharing.
My name is Natnari from Big Data Analytics class, and I am here to introduce you my term project. My data analysis term project is about the used car dataset. The problem statement of this data analysis is that when we give the new information of the used car, it can predict at what price this particular used car can be sold by using the year of the car, present price, kilometers driven, seller type, transmission, and owner. The purpose of this project is to determine if the price of the second-hand car is worth the price it's offered or not. And I think that isn't just about determining which car is superior, it's also about determining which is the most appropriate price for us. The objectives of this project is to make sure if the second-hand car we're gonna sell, if it is overpriced or underpriced. And I believe that this should benefit many people in different ways. We can also know that which brand of the car price dropped the most when it comes to second-hand. The workflow of this data analysis is that firstly, we download the data, which in this case is from Kaggle. After that, we play with the data for visualization and process it. The reason of doing this is that it is an important step prior to processing and often involves reformatting data, making corrections to data, and the combining of the data sets to enrich data. Then we are doing a trend test split, which is a function to split test and trend data to be ready for the linear lasso regression. As I mentioned earlier, I've got this data from Kaggle, which is an online community for data scientists to obtain and gain information from. This data is provided by a student at the University at Buffalo in New York. The data consists of 9 columns and 301 types of car. After we have completed importing the data, the first thing we are gonna do is to do the data visualization to have a better picture of the data. The one on the left, I compare the kilometers driven to the year of the car to see the average range of the car usage in each year. And the other one is showing at what price of the used car having the highest quantity of the car. Next, we are playing with it. It is to inspect the data by using the function called head. This shows the first 5 rows of the data, and if we want to see more from the list, we can just type the number into the brackets. The shape function is to check the rows and columns of the dataset, which in this case is 9 columns and 301 rows. The info function checks the information of the dataset. Next is checking the missing value. followed by checking the distribution of the categorical data, which in this case is counting the same type of data. For example, in the fuel type column, there are 3 types of fuel, which are petrol, diesel, and CNG. So it's count how many of each. This histogram shows what I have mentioned earlier in a better picture. It can be seen from the graph that the most popular fuel type is petrol, and people like to sell their car more via dealer, and most of the car is manual transmission. Next, we will be doing the data preparation by starting with replacing the float data by integer, because to make it possible to plot in the scatter. So in this case, we replace petrol with 0. And here it's come out like this. We split the data to make it in a different axis because we want to compare it, and also dropping the one that is unneeded, which in this case is car name and selling price. Then we try to print what we have split and set the test and trend size, which in this case we have done an 75 to 25 split on data. 75% of the data will be used for training, and the rest 25% of the data will be used for testing. Here's the result of the linear regression. The accuracy of the training model is around 88%, and the testing model is 83%. Moreover, I found that there is a method called lasso regression, which is interested too, so I decided to try it, and the result came out that the accuracy of the testing model is a bit higher than the linear regression.
Okay, very good. You at the end of the day, even though you have many factors, you're just making a simple regression, right? It's just one variable, correct?
Yes,ค่ะ.
What's x? What's x again? What's your x? Y is a linear function of x. What's x again?
Give me a...
What is your independent variable? What's your x? You have mileage, you have types of fuel, you have types of seller, and so forth. And in the end, you ended up predicting y as a function of x. What is x?
It's the predicted price of the used car.
No, that's y. What's your x?
Actual price.
So you... Okay, so on your screen, you should have a y as a function of x, right? You do a linear regression. Y is an actual price, correct? Right?
Yes.
Okay. And you predict that using a linear function of x. What is x?
It's the actual price of the car.
So you're regressing actual price with predicted price?
Yeah.
And where do you get the predicted price? So I think you're just showing what so predicted price is like a blue book price, right?
Yes.
So it's not really a prediction model, is it? Right? Okay, if I'm going to predict your height as a function of your weight, okay, x is your weight, y is your height. Okay, in this case, you actually have one x is an actual height, the other one is predicted height. So somebody already did the prediction for you.
Oh, I see.
So this is not really a prediction problem. You're just visualizing how much the actual price deviate from the benchmark price. I think when you have a sale, when you have in the used car market, you can look up this model, this make, this model, this year, this mileage, and it will give you a rough estimate of how much you should get, right? All you're doing is just showing that actual price deviate from that, but you're not making any prediction because that is actually a base. It's the same thing, right? So your x and your y is referred to the same thing. So I think you are confusing visualization with making a regression problem, right? This is not a regression problem. Okay, you're just showing how much actual market value in America is called Kelly's Blue Book. Okay, so Kelly's Blue Book value on the x-axis and y-axis is the actual price. That's just normal deviation, right? Because when you try to sell a used price, you look up Kelly's Blue Book, and that Kelly's Blue Book said this is worth $1,500 or $15,000, right? But because you have a particularly low mileage, or it's very clean, it's used by housewife and it doesn't get trashed about by teenagers, so it gets higher price. So it's higher. This is you're just visualizing the deviation of a used car market, variability of used car market from the baseline value. You're not making any prediction. Okay. Moreover, I think you are confusing. What I told you would be the simplest thing to get confused is between ordinal value and a nominal value, right? So field type, is it ordinal scale or is it nominal scale? Answer. You have to answer that. Okay, I think you get that confused as well. So again, I ask you to be very careful that to make distinction between nominal, ordinal, interval, and ratio scale. That is the simplest thing. That is lecture 1. Okay, you shouldn't be making that kind of a confusion at this late of a stage. Okay, but the presentation, I think, is very good. It's well organized. Okay. Who's next? Who's up? Benedict, right? Okay, that's Benedict.
Hello ครับผม Whoops. I think I have to restart Zoom to share my screen. I haven't enabled it in my computer.
Okay, I think we can go to Piriya. Are you ready for that? And then
Piriya,
we can
if you're
go back
ready,
to
you can
Benedict.
go ahead, and we'll put Benedict back to the back of the queue. Okay, so just maybe deduct a point for not being ready or something. Okay, Priya, if you're up, go on.
So this is my big data project presentation. This project is retail inventory management. I plan to develop a model that can classify types of products that are trending and find their common product pair. The purpose of this project is to find the popular products and their common product pair, to help department stores and retailers to manage their inventory, increase their sales, and prevent shortages and overstocking. The method that I use in this project is market basket analysis, because I want to find the hidden structure and relation among data. So unsupervised data mining is perfect for this project. The dataset I use is called Online Shopping from Kaggle by Tanya Dayanan in 2020, which has the data that is important to inventory management, such as order ID, product ID, customer ID, sales, and etc. For the coding part, I use Mathematica to code, so the first process is to find the popular product by using count and sort command. Then I use bar chart command to plot the graph, so it's easier to see. As you can see in the graph, the first bar is the most popular product, which is product 6. It appears 1,225 times. So next is to find the product pair by making the same order ID be in the same rows. So it can be more than one product ID per one order ID, because the dataset I use has only one product ID per one order ID. Then find the number of baskets that have more than one item, and the number of baskets that have popular product in them by using select command. And then use select command again to see the number of baskets that have only one item, and the number of baskets that have only product 6, which is the most popular product. After that, I use length command to see the number of all baskets, like how many bills are there in the dataset. And I find the percentage that people will buy popular products, which is 20.89%. So this formula is for finding the percentage that people buy the individual product For example, people buy product 1 only 9.75%. And then I find the number of baskets that people buy popular product with other products. Like the customer buy product 6, which is popular product with product 1 for 74 times. Then I make it be in the table form so it's easier to see. Then I use this formula to find the number of baskets that people buy product A with product B and make it be in a table form. The example is this one. People buy product 1 with product 2 only 22 times. But this data is not all correct because I already solved my dataset and some of the pair products do not exist. For example, product 4 pairs with product 3 does not exist because it already appears in product 3 pairs with product 4. To say it in short, it's about the order of the product name. So I use this formula to cut down the non-existent data out, and this table will be the correct one. And this is my map that I made. The mind map contains 3 main topics. The first one is project overview, which contains description, purpose, and method that I use in this project. The second one is dataset overview, which contains my target data and metadata of this project. The last one is process, which tells all the coding steps of the project. And these are the references that I use. That's it for my presentation. Thank you.
Okay, excellent. In fact, this is the first presentation that shows a reference. So I like that very much, okay, because obviously you didn't invent any of these techniques. So it's good to get references, so get extra points for that. Very good. This is actually the only one I've seen so far that does any kind of reference. Okay, you presented a little bit more of a detailed calculation, which is okay. Sometimes it's okay to take a step-by-step explanation so people can follow through what you did. Having said that, for market basket, I think there are visualization method that would show which products pairs with what and so forth. So perhaps we can focus more on presenting the result and the insights. For example, you can say something like you've sorted out the most common product pair, the top most, think of a sales pitch, think of a marketing speak, think of a marketing meeting. The marketing meeting, your department store manager might be asking, well, what are the 3 most popular product pairs? Okay. Or given that we are looking at product number 1, 1, 2, 3, 4, what is the 3 most popular other product this thing pairs with? So there are different ways of presenting market basket analysis to make it more interesting. Okay, but and then that's good. By the way, the mind map is good. I actually didn't ask specifically for you to produce your own mind map. I just wanted you to highlight on my mind map where it fits. Okay, but if you took the extra work to draw up a mind map from scratch, that's even better. But that's not. I didn't ask for that. Okay, but you can use that as your presentation. For the presentation in the paper, you can use mind map in figure. I would suggest that you crop portion of it at a time. So the mind map is if it's too big and you put everything in one page, it's just going to be too small to see. Okay, Kap. So do we come back to Benedict? Very good, Kap.
I think I can do it now. Yes, I can.
Okay, go ahead. You're up.
Okay, I'll play my video. If you can hear the sound, tell me, please.
Presentation for data analysis. It's about alcohol consumption related to happiness. My name is
You can hear, right?
Claire, and I'll walk you through my project. So the introduction for my project is alcohol is the most widely used substance in the world for socializing. Since I also partake in socializing from time to time, I would like to know if alcohol really makes you happier. Although I have my own answer for my experience at the end of this presentation, so keep to the end and you'll see my answer. The objective is to find the relativity of alcohol drunken in different countries to the happiness level, and maybe some other things that is in the data set as well. I'll be using a data set that will contain data from all over the world. So let's look at the data set. My data set is about happiness and alcohol consumption. I got it from kaggle.com, and the columns are, there's 122 countries, 9 regions, North and South Hemisphere, a happiness score index, which is ranked from 1 to 10 from each country. There's also the Human Development Index, which will determine the well-being of the people in those countries. There's also the GDP, beer, spirits, and wine per capita of each country. So let's look at the methodology. My methodology is visualization and supervised linear regression model. For visualization, I have this bar graph, which will visualize the amount of beer and spirits and wine drunk in the whole world. And as you can see, beer is the most widely drunk alcohol substance in the world. This graph is the distribution of happiness scores of each country and how happy they are. There's also this visualization list line plot, which the left one is the happiness scores to the beer data, and the right one is the GDP to the happiness scores. And there's also this one, which is the happiness score to the HDI data. This will show us the correlation between these kind of data. This is a pie chart, which is the happiness levels by every single region. And as you can see, the Australia and New Zealand region is the most happiness region in out of all the regions. This is a bar chart which shows the beer consumed by each region per capita. Western Europe and North America has the most amount. The next one is supervised data. So I tried using linear regression to do my data and analyze my data. These are the coefficients to the data, which is the HDI, GDP, the beer per capita, spirits per capita, wine per capita. And these are the estimate scores. So I also tried to train the data, but I ran into a problem, which is I tried to find the error, but I can't because the data wasn't capable of doing it. And here's the correlation matrix of my data. This kind of worked, and I kind of seen results. So this is my mind map. It's really hard to look here, but I have chose the ways that I went through for this project. I have a file separate that you can see, and I will send along with this video. So let's just go to the conclusion. So the conclusion is, it's interesting to see that a little bit of correlation between alcohol and happiness levels. As I said, like with beer, there's a few correlation, but I feel like there's not enough features to be able to completely define the happiness score. So you can't really use just the alcohol to define like whether this country is happy or not, because there's also things such as the GDP, the HDI index, and like just with alcohol alone, you cannot define the happiness levels. But it's interesting to see what I could do. So as I said from before, my personal experience from not looking at data is that no, the happiness is temporary and there's many regrets once you drink alcohol. You may be happy at first, but then after that, you're gonna regret it. So that's the end of my presentation. Thank you very much for listening.
Okay, Kap. As I indicated, you are not required to use machine learning model. You can use statistical method as well. Okay. However, if you choose to use statistical method like linear regression, then you have to present it properly, right? Remember that in linear regression, not only do you get the regression equation, you get the coefficient, you get the significance, you get the R square, you get all kind of analysis that comes with it, because it makes an assumption on the linearity and the normal noise, right? So if you're doing, strictly speaking, a linear regression or multi-variate regression, you have to present all the statisticals that result that comes from it, right? The coefficient, the t-test, the R square, adjusted R square, and all that, right? Now with machine learning, we try to do that. We try to get as much accountability for the accuracy of the model as we can, but we don't get some things like, you know, significance, statistical significance of the coefficient. With linear regression, you do. Okay, so if you decided to do that, you have to present all of that. You can't just say, I'm just going to do linear regression and then just give a qualitative insight from the end, you know, to say, okay, it's a little bit positive, it's not so positive. Well, how much is it positive? What's the correlation? What's the R square? What's all this is available in standard statistical linear regression software, right? So this would have to be presented. Okay, so again, that would be something that needs to be addressed. Okay, so Piriya, right? Piriya, you up?
I already present.
I think it's me.
Oh, sorry, my bad. So
the next queue is Jen Jira.
Okay, นัดต้องให้ก่อนล่วงหน้าพี่นึกว่าเป็นคนนี้กันแหละโอเค sorry นัดมีตารางนั้นใช่ไหมจ๊ะที่พี่ให้ไปอ่ะอย่างตอนนี้
ผมมีใส่คิวถัดไปไว้ในแชทครับ
โอเคในเจนจิราแชทไหนอ่ะ
ของซูมครับ
โอเคของซูมนะโอเคนัดทำในซูมโอเค sorry my bad โอเคครับโอเค so Jen Jira you up
I'm sorry, I cannot hear your voice.
You have to connect the sound. It looks very good, but I can't hear anything.
Maybe you have to unmute when you share.
Okay.
Okay, loud and clear.
Hello everyone. Can you hear it? Today, I will present you my big data analytics project, World Energy Sources using Mathematica. So my data description is energy production source of every country in the world that can be retrieved from 1985 to 2020 in percentage. My data includes nominal scale, ordinal scale, and ratio scale. My value is 6,191 rows. I visualized composition, movement, and also relation. The machine learning I used is supervised learning. Includes decision tree, nearest neighbor, logistic regression, and naive Bayes. Now let's jump into my analytical project. I am the one who loves nature. That's why I'm interested in sustainability and concerned about the pollution. That makes me curious about clean energy adoption our world is on, or Thailand, what Thailand is doing. Those questions made me to choose this dataset. So the objectives are visualize sources of energy production in time series and proportion, and create interactive tools, classify countries according to level and way of clean energy adoption rate, find the countries for Thailand to be the models of clean energy adoption in the future. My data is retrieved from Kaggle, including 235 countries and regions and 9 source types. The data is arranged country by country. So what does the data directly tell? It tells trend of energy sourcing around the world, energy sources proportion each year in a specific country, and comparative energy sourcing trend around the world, which I also grouped the energy sources. You can download my manipulable visualizations I showed via GitHub. My classification started from separating the countries successfully use mostly clean energy from the countries which are not, and then find that it moves toward renewable or nuclear, or just still to fossil fuel. So I have to form the secondary data, which are groups of energy source percentage and slope of linear model fit of the trend. That's how I can have my x and y. X is the slope of renewable train linear model fit minus slope of nuclear train linear model fit. And the y is the opposite trend of slope of fossil fuel trend. I also concluded it in the decision tree form. Here is the result. I found that only 35% has already adopted clean energy for more than half of their generation. The logic works very well, and it divided countries into groups. I also found that there is no country using nuclear energy alone. And Thailand is among 36 countries which are in adopting stage by never generating nuclear energy. How interesting is the data also tells the world adoption too, which is in adoption stage. However, my data has abnormalities too. Some years of Europe countries are missing, and some data are not country. I tracked them and I handled them already. Yes, that's it. I got the answer, but let's train the machine to do it as well. I parted the data so I can have training set and test set. Firstly, I decided to train the machine 3 times since it has different matrices to focus. So my first classifier is to classify between adopted or adopting. The results turn out that it used logistic regression and the accuracy is 100%. The second classifier is to classify among the adopted countries, which it used nearest neighbors and the accuracy is 71%. The third classifier is classifying among the adopting countries, which it used nearest neighbors method, and the accuracy turns out to be 54%. But after I did my 3 classifiers, I have just realized that I can train all of them in once, just including all the variables used. It turns out that the method it used is naive Bayes and the accuracy is 60%. From the machine learning performance, I found that it did a perfect job to classify between adopted and adopting countries. However, to classify using slope value has only about 60% of accuracy. I think it's because the criteria is the sign of value and the logics are too complex. Comes to conclusion. Now I can get the appropriate development model for Thailand and also the target for Thailand to achieve. For example, Cambodia, our ASEAN member, which has successfully used mainly clean energy. I finished my job by concluding all country in a dataset and prepare function, as well as plot in the map divided by the classification. Last but not least, the application and improvement. First, this data and implementation can use to focusing other countries too, not Thailand only. Second, I also should test my classifier functions more. And finally, the clean energy adoption depends on many factors. So this data can be used with maybe GDP data or population data to find more insights. Thank you.
Okay, Cap. There's a little bit of construction at July. Okay, so this is very good. Yeah, this is actually what I meant by using the mind map to locate your problem, right? So literally that's what I wanted everybody to do, which is to go through the mind map to say this is what my data looks like and what are the techniques I'm using. It seems like a very interesting project that's a clever use of data source and combination of machine learning. Now, I'm not a little bit unclear, and we don't have time to go over this, but we're a little bit unclear as to the target, right? If your target is adoption, it might be the case that if the target is adoption and your X value is actually definition of that, you kind of like, you're not making the proper prediction. You see what I mean? It's like you create an index of adoption and you're predicting the value of the index based on the content of the index. If that were the case, I'm not sure if that were the case, but from listening to you quickly, there might be a little bit of that. You see what I mean? So if, for example, X1 is use of clean energy and X2 is decrease of coal or something like that, and then you use that to predict the adoption, but the adoption themselves takes into account the X. So it's sort of like not a prediction, it's almost by definition that you're gonna get a good fit. Now check if this is the case. I can't tell from just listening very quickly, okay? If this were the case, then that has to be corrected, right? Because you can't predict Y if Y is defined partially from X. So be I think that the problem definition has to be spelled out a little bit, but I look forward to reading the report. So this looks very good. Okay, Kap. So now you have that, right? The next person, so I don't have to put that in the line, right? Okay, in the Zoom. Okay, Kap. So next person would be what?
สรวิทย์
ครับผม yeah
what okay, so okay. Now there's another person who wants to do this week, all right? Panathon and another person, Nat. มีคนใช่ไหมครับ
มีอีกคนครับ
โอเคครับอีกคนคือกนกวรรณเนาะ
กนกวรรณครับ
Okay, so let's have Kanokwan go in. Right now we have Soravit, right? Soravit. Next one is Panathon, and then Kanokwan after Panathon. How's that? That okay?
Okay.
Okay, Kap.
Knowing customer is very important for business. Can you guys hear it?
Yep.
Knowing customer. Okay. Knowing customer is very important for business owner. This is why I choose to do customer analysis for my big data final project. My name is Soravit Vashyatanusan. Let's begin. This is the agenda for today. We are going to see what data set, what methods I use in this project, what question I had when I first saw the data, how did I do the data preparation, which library I use in this project, and how do I do analysis, and then make some insight and inference, and then lastly, answer the question after doing the analysis. Okay, so for the data, it has a total of 29 columns with 2,240 rows. After seeing the data, we can divide them into 3 parts. The first part is about the customer's personal data, the second is about the purchasing data, and the third is about the promotion data. For the methods of the analysis in this project, I had in mind that customer segmentation will actually provide the store with better understanding of the customer lifestyles, behavior, and so on, and this will actually give the store insight on how to maximize the value of their customer based on the data in their possession. So analysis will be divided into 2 parts. The first one is analysis based on visualization, and the second part is analysis based on customer segmentation using K-means algorithm. Here are the questions that I have. Moving on to data preparation, I first dropped the unnecessary column, which was ID, and then removed the rows with missing values, then created 3 new columns, which are age, spent, and total children, which will give clearer picture for the analysis. And then for the marital status, there are various type of status, so I just classify them into 2 categories, which are single and partner. And then lastly, I remove the rows with some outliers. This is the data after modification. You can clearly see that the number of rows and columns are changed, and this is how the data looks like. Python library I used in this project are NumPy, Panda, Matplotlib. These 3 are basic for data analysis, and Seaborn will be used with Matplotlib for visualization. And for the K-means algorithm, I used from sklearn cluster library. For the analysis of visualization on Wolfram, I first imported the data into Mathematica and then assigned variable to the data that I will be used. For spending distribution, we can see that majority of customer, or 800 customers, spends around $200 to the store. And the marital status, we can see that majority, or the 2/3 of the customers, have partner, while 1/3 of the customers are single. To see whether marital status affects spending, I use Python to find the average for the spending for each marital status, which are single and partner, and then compare them. And we can see that the average spending for customers who are single is higher than those who has partner. After comparing children and the spending, we can see that customers who don't have child spend more than those who have, and the more child customers have is the less they spend. For age and spending, there is actually no correlation. But for the income and spending, we can see that the graph is linear, which means the customers who have high income tend to spend more than those who have less income. In this store, wine is the best seller, followed by meat, gold, fish, sweets, and then fruits. For the customer segmentation using K-means, the goal is to divide customer into tier-based group like bronze, silver, gold, and platinum. But before we do anything, we have to find the reasonable number of cluster. I use the able method for this. Okay, so for the first step is to extract the column that we want. In this case, we want income and the spending, then assign variable x to them. And the next thing is to find the number of cluster using WCSS within cluster sums of square or the elbow method that I mentioned. In this case, the optimum number of cluster is 4. After knowing the number of cluster, I start training the k-means algorithm, then assign the variable y to the trained model. After plotting the clusters, we can finally locate the tiers, and then we can replace the tiers to the element in the variable y, which we can see that majority of customers are silver, followed by gold, and then platinum, and then bronze. After all the process, I can finally find the insights based on tiers of the spending behavior, purchasing behavior, and the promotions used. These are the insights and inference from all the analysis that I have done in this project. After getting all the insights and inference, we can finally answer all the questions that we formed in the first place. And this is it. Thank you for listening to my presentation ครับขอบคุณครับ
Okay, Cup. Very good. I think you're quite clear on what you wanted to do. There's only just one thing. Just make sure again you don't confuse nominal with ordinal. Okay. When the result of the k-means analysis is basically different clustering. Okay. Different clustering just means that they are different. So essentially, it is nominal scale. Having said that, you only look at the result of the centroid, and then you can say that, oh, this cluster is actually preferred to other cluster. Okay. Sometimes you can do that, sometimes you cannot. Okay. For example, let's just make an extreme simple case. There are two clusters, right? One cluster is good with respect to A, but bad with respect to B. The other cluster is good with respect to B, but bad with respect to A. In which case, they're just different. You can't say which one is better. Now, if you make the cluster and it turns out that in both criteria, cluster A is higher or equal or higher. So for example, cluster A is the same with respect to criteria 1 as cluster B, but with respect to criteria 2, like customer loyalty, is much better. In which case, you can actually impose an ordinal structure, right? So bear in mind that when you run clustering analysis, unsupervised learning, the first shot you get is just that there are different cluster of people, okay? And that, strictly speaking, is just a nominal scale, okay? It becomes an ordinal scale when you analyze the detail of the centroid and you say, oh, I prefer this cluster better than that cluster, okay? So you shouldn't have that gold, silver, platinum before you do the cluster analysis. It should be after you do the cluster analysis and then you realize that, oh, okay, maybe there's something about cluster 1 that is better or equal to cluster 2, okay? So again, the message is that you only get to ordinal ranking when you analyze the centroid of the cluster, okay? The cluster itself just say that people are different, no better, no worse. It's only when you examine the details, okay? So be very careful with that. But other than that, it's a solid work, okay, Cup?
Thank you ครับ
ครับผม
โอเคครับ next is ธนาธรครับผม
โอเคธนาธรวันนี้ที่ไปฉีดยาเนาะโอเคครับ
ครับ
Can you see my screen ค่ะ
ค่ะก็ให้ค่ะ
is most commonly linked with young women. Although the abortion is most commonly linked with young women. Although the abortion rate is greater in younger women, it is a procedure that women may require during their reproductive years. Some women receive abortions because they believe they have become too early to be parents. However, it is a complicated matter and should not be presumed that only young and unmarried women get abortion. In truth, the abortion rate in the United States has been decreasing for younger women while increasing for older women. What are the statistics on the ages at which women get abortions? This project utilizes Mathematica to illustrate interactive visualization tools, state comparison, and age at which women get abortions analysis to baseline fit using a fundamental supervised learning algorithm. This project aims to develop machine learning on performance data to achieve the following finding objectives. First, the trend of abortions over a time period in different states. Second, the pattern of how age affects the number of abortions over a time period. And lastly, the best and most accurate model in prediction. This project scope includes manipulating and taking observations of the abortion data in different states in the US. In this case, the data between the year 2007 and year 2016 was used to compare and identify the trends. The reported abortion by known age groups in the selected areas were used to explore how age affects the number of abortions. Finally, a prediction model for predicting the number of abortions in the next 5 years through linear regression. As shown in Figure 1, the mathematical function bar chart is used to display the abortion statistics between the year 2007 and 2016. The graph visualizes different states in the US horizontally. The manipulate mathematical function allows the user to select the variables they would like to view, whether it's the number, the abortion rate in women aged 15 to 44 years old, or the abortion ratio per 1,000 lives birth. In Figure 2, Mathematica does provide a geo-bubble chart function capable of displaying multiple states on a map by their location. The relative size of the bubbles represent the value of abortion. Figure 3 is a visualization of the number of abortions based on age groups. The horizontal axis represents the age groups, while the vertical axis represents the percentage calculated from the amount of abortion divided by the total abortion reported by known age and multiplied by 100. The user can choose the states for visualizing the abortion data. The first methodology I use is the comparative analysis. And the purpose of this analysis is to identify the prevalent trends using Mathematica's built-in function list line plot to display continuous data over time and instantly see the relationship made. This comparative analysis addresses how age affects the number of abortions and observes the trend based on age groups. The data has been visualized into a bar chart based on all 45 selected states, and the graph shown in Figure 5 compared different age groups and displayed the data changes between the year 2007 and 2016. According to the graphs, similar patterns in which the percentage of abortion in younger women, age groups under 15, between 15 to 19, and 20 to 24 years old decreases, whereas in older women, slight increases occur in almost every area. In today, pregnancy-related school dropouts are becoming a source of public awareness. Seeing the positive change in abortion statistics among individuals between 15 to 24 years old, I was curious to see how this decrease in abortion affects the rate of teens dropping out of school. A hypothesis was made: as the amount of abortion has decreased among teens, the dropout rate would also result in the same direction, which showed that fewer unintended pregnancy has occurred. The prediction analysis uses the Mathematica's built-in function predict to forecast the amount, rate, and ratio within the near future. Here, the method uses linear regression. The predictor measurement has taken 10 test examples from amount, rate, ratio file to compare the predicted value with the actual values. The most accurate line is then created and used to forecast the trend from 2017 to 2023. After exploring how age affects the amount of abortion, the next methodology is to predict the number of abortions in the next 5 years, according to the trend based on different age groups observed earlier. The abortion data from each groups are fitted with the linear equation using the Mathematica's built-in function linear model fit. In conclusion, the trend of abortions over a time period in different states in the US has constantly decreased between 2007 and 2016, resulting from 1 in 3 to 1 in 4 women having abortion. The number of abortions reduced to 623,000 in 2016, a 32% decrease from 2007. The abortion rate fell to 11.6 abortions per 1,000 women aged 15 to 44. The abortion ratio also correlates with the declining birth rates, implying that fewer women are becoming pregnant and having access to contraception due to awareness issues. Meanwhile, women in their 20s accounted for the majority of abortion in 2016 and had the highest abortion percentage during the study period. The amount of abortion has significantly decreased among younger women in age groups under 15, between 15 to 19, and 20 to 24 years old, and become more common in later life for women. As a result, it is a good sign for young women and is mainly due to the improvement of contraceptive use and cultural trends against abortion.
Very good. I think you got the basic done very well. Okay, a good blend of starting with the visualization of factors, then trying to just use a simple regression or prediction to basically extrapolate. Of course, with time series and stuff, it's a little bit tricky, by the way, to make a linear fit into the future because first of all, a linear line can cross zero very easily. So you have something that has to be intrinsically positive, like a ratio number, and you make a prediction, and then it goes to negative number. Okay, so a linear regression projection into the future is a little bit tricky. Okay, but it's okay to use it as long as you qualify that you're just trying to visualize like a trend over the next year or two. It's not a long-term trend. It's not a long-term projection. I think you got the basic of mix of analysis and presentation right. I would add that to make this really good, once you get to the result, you actually have to sell the the climax or the highlight. The highlight is your insights. Okay, so I'm quite surprised that you did a lot of visualization of the factors and so forth, but when you get to the final conclusion, you just have a blank page to say the conclusion, and I think it would make a much more interesting presentation if you spend some effort on presenting. It doesn't have to be interactive tools or anything. You already did that. It could be just bullet points or graph or something like that, or stylized fact. So it's very important that you did the decent work already, but you want to capitalize on it. You say, okay, this is my finding. My finding is that the only thing I got from not seeing any graph but just listening is that you used to think that it's a young people thing and it's more like old people. Having said that, the only thing I would not the only thing. Another thing I would add as caveat to your study is that you have to be very, very careful when you do this kind of analysis on demographic data, that you define your baseline right. Okay, you can't say that nowadays there's a lot more people, older women are getting abortion compared to young women. Well, it could be because it's an aging population. Okay, so before you jump to that, it's extremely important that you're dealing with demographic. Is a shifting picture frame. You're not taking one picture and you say, okay, let's look at it again. The picture has to move, so your frame has to move. The population moves. So again, the simplest thing I can mention is that, well, how do you know that there's actually aging proportion? You say it's an aging proportion is higher, but that could be because demographic makeup already changes, right? There's a lot less young people. So be very careful about what you select as your baseline. Okay. Now, if you did that, okay, and you control for that, and then you find net effect over and above that, that becomes interesting. That becomes interesting. I think you've done the good coding, the programming, the tools. You built up the right tools. You haven't quite done the analysis yet. Okay, I wouldn't read your paper for the result, but I would like to see how you make the tool. That's very good. Okay, okay, Cap. Should we have like a 2 minutes break so Peanut can start the video and I can make a quick hop to the coffee room too. Okay, Nat Cap.
Okay, thank you.